I welcome you once again. I teach physics and mathematics, both O-level and A-level. My name, Kateriga Hussein, but I'm here today, Physics Senior 2, majorly. We are going to talk about physics, Senior 2. Senior 2. Under this physics, we're going to talk about mechanics, but we are under turning effects. Turning effects of force. Now, when we talk about turning effects of force here, we should get to know that everything you are going to hold, there must be a force, but it's like opening and closing the door. You open the door, you close the door. It is a turning effect which is acting there. So, under turning effects, we are going to talk about moments of force. Moments of force, we are going to know the definition of moments of force and the SI units and some of the factors affecting the turning effects of force. Moment of force, this is the product of force and perpendicular distance from the perpendicular distance from the action of the force, from the action of the force to the pivot. That is the definition. Here we have the force and the perpendicular distance from its line of action, from its line of action of the force to the pivot. Now here we have the turning point. It's like when you are on seesaw. There is the turning point. This side there is a pivot. The other side there is a load. So where I have the turning force, now the pivot and the load is the forces. And the distance from the turning point is known as the perpendicular distance. So we should get to know also the formula here. We say IE. Now we talk about the product. Product means that there must be we are going to multiply. That meaning of the product. Moment of force is equal to the force times perpendicular distance. And we talk about this one in this form. We present this one in this form. We say that F times D, where the F is the force and D is the distance. And when we move ahead, we are going to talk about the SI unit. The SI unit of moments of force. Moment of force. Now, to get the SI unit of moment of force, look at the formula. This is the formula. Moment of force is equal to force times perpendicular distance. What is the SI unit of force? Is in Newton. What is the SI unit of distance or length? Length, the standard one is measured in meters. That's why if this one is in Newton and this one is in meter, automatically we are going to be Newton meter. Those are SI unit of what? SI unit of moment of force is Newton meter. The bracket, capital N, small m. Those are SI units of moments. We are going to talk about also the factors. We have the factors. Factors affect determining the turning effect. The turning effect of force. Now, my dear students here, you should get to know that when you are talking about the factors that are determining or that affect the turning effect of force, you look on the formula. What is there on the formula? We have the force and perpendicular distance. We are going to talk about the two there. We have the force and perpendicular distance. The magnitude. When we have the magnitude of what? Of force. Because it is there. And we have also a perpendicular distance. You'll find the question, just set the two factors that affect the turning effect of force. Those are two factors. Now, we move ahead and talk about some of the principle of moments. Principle of what? Moments. It's like having this ruler and this duster. Now this one is going to act as the pivot. We have the ruler. The ruler is starting to balance. Moving this side over the other side. There is clockwise and there is anti-clockwise. So, you should get to know that the moment of force, when a body, it states that when the body is in equilibrium, the sum of clockwise moment about that point is equal. We are going to talk about that one physically. You get to know is equal the sum of anti-clockwise and anti-clockwise moments. Anti-clockwise moments about the same point. Now, you should get to know that when you talk about the sum, there is this point. Now this one is going to act as our turning point. If we press a ruler like this, and the ruler is not balancing, is moving in that form. There is what we call clockwise and anti-clockwise. This is sum of clockwise moment is equal to the sum of anti-clockwise moment. So, here, what you should get to know? You should get to know that, i.e., if we consider the diagram, consider the diagram below to illustrate that. So, here we have, this is our meter rule. We have the knife edge. This is what we call knife edge. It's not a miaka, but it's just an edge, not years. We have a force here, force 1, and we have the distance. We can say distance D1. We have another force here, force 2. We have a distance 2. It's like someone sitting the other side, another one sitting this side, and you try to balancing like that. You are moving clockwise, you are moving anti-clockwise. You want that in that form of the principal moments. Now here, we are going to apply our formula. Where? Here, the formula of moments is equal to force times perpendicular distance. So here, when you apply the principle of moments. When you apply the principle of moments, here, you should get to know the principle of moments says that when a body is in equilibrium, the sum of clockwise moment about the point is equal to the sum of the anti-clockwise moment about the same what? Point. This is the same point. So, we have this side is pulling this side, you are going down. You need to go down. This one is saying, I'm not going down. There is clockwise, and there is anti-clockwise. This side there is anti. I'm not going. This one is saying, clock, you go down. So, there is two forces there. That's why we say, now here we're going to we have clockwise moment. There, clockwise moment, the sum, always can say clockwise moments is equal to anti-clockwise moments. So, here we should get to know that moment, we said that moment is the product of what? Of force and perpendicular distance. This is the force and perpendicular distance. When we talk about clockwise moment, this side is clockwise moment. We have the force, which is the 2, which is F2, and perpendicular distance, which is D2. We are going to say F2 times, because we talk about the product, times the perpendicular distance, which is D2. So, is equal to force 1 times D1. This is the formula we are going to try to apply in our examples. Shall we get to one example and we see? Example 1. First examples, we have 1 here. We are going to say, we have the diagram here. We have a force here. We have 20 newtons. And we have X. The distance from here up to there is 2 meters. We have the distance from here up to there is 4 meters. So, let's say if the system is in equilibrium, comma, find the value of x. So, we are going to find the value of x. But how? Applying the principle of moments is the only way. When you look on this diagram, we have this one is pulling this side, the other one is pulling the other side. So, what you should get to know that there is anti-clockwise moment and there is also clockwise moment. So, applying in our solution, we are going to say apply the principle of moments, principle of moments. Apply the principle, the principle of moments. So when we apply the principle of moments, we set a sum. We don't know how many. That's why we place the sum. Sum means we are going to add. We add this one, we add the other one, but we don't know whether the forces are how many, but we use that word, the sum. The sum of the forces, the sum of clockwise moment, sum of the clockwise moments is equal to the sum of anti-clockwise moments. So, look where there is a side of clockwise moment. We have what? X. The distance we have what? We have 4. But our x here is the force acting perpendicular. That's why it is acting here perpendicular. So we say force, which is x, times the distance 4 is equal to, we have another force here which is 20 times the distance, which is what? 2. So that is small mathematics. We are going to multiply and we get the correct answer, and we say only try to multiply and we have there x times 4. We have 4x is equal to 20 times 2. We are going to qualify to get 40. Our next step here, we are going to divide both these sides by what? By 4. When we divide both sides by 4 here, x is equal to 40 divided by 4, and our x is equal to 10. But 10 what? Remember, x is a force, 10 newtons. I hope we are at par. So, we are going to try another example. Okay, now we are saying the diagram, the figure below shows the beam acted upon by three forces. Let us have this beam and we see. This is the beam being acted by 3 forces. We're going to identify. We have one force here, 20 newtons at a distance of 3 meters. We have another force here. This force is P at a distance of 6 meters. We have another force this side. Force which is 6 newtons at a distance 0.1 meter. I'll make it 60 newtons at that distance. They say if the system is in equilibrium, find the value of P. We are going to find the value of P. This one, there are forces acting up and the forces acting down on the beam. But you need to identify which force is in clockwise moment, which force is in anti-clockwise moment. You need to get to know that. So, after verifying that, you will be able to calculate. Now, if you try to see this one is pulling this side downwards, but the other one is saying, I'm not going. This one, they say, you need to go down. Can you identify? You are seeing that force 20 is in clockwise moment. Force P is in anti-clockwise moment. And force 60 is also in anti-clockwise moments. So when you apply the principle of moments, apply in our solution, we are going to say apply the principle of what? Of moments. So, when we apply the principle of moments, we talk about the sum of clockwise moments is equal to the sum of anti-clockwise moments. Remember, we try to identify our clockwise and anti-clockwise. When you come on clockwise, we say that this one is clockwise. We have 20, which is the force, times the distance, which is what? 3. The distance from the turning point, this is our turning point. Or from the pivot, or from the fulcrum. This one, the distance from here up to there. And we have another one. When you identify, we don't have another one. Is equal to, we have P times the distance, which is what? 6. Plus, we have another one, which is 60 times the distance, which is 0.1. So, when we try to multiply this, we have 60 is equal to 60p. And when we multiply 60 times 0.2 plus 60. So, what we do? We collect like terms. This 60 come this side. We have 60 minus 6 is equal to 60p. What we do again? We divide both sides by 60. Our P, after subtracting, we have 54 divided by 60. And the answer, our P is equal to, when you divide by our 54 divided by 60, we are going to have 9 what? Newtons. Therefore, the value of P is equal to 9 what? newtons. That is applying the principle of what? Moments. I hope we are there. We are going to move to experiment 2. Verify the principle. The principle of moments. We have, when we are calling this, physics is divided into 4 parts there. We have, they talk about the definition, they talk about the sum of the experimental part, or describe an experiment to verify the principle of moments, or to determine each and everything. And here also there is a small part of there is a part of calculation, and there is that part where you are going to get to know what to explain why this one is like this or why it's like that. So you need to get to know that there is experimental part. In this experiment, what you should get to know that you are not going to carry out practically, but must be theoretically. Now here, when you are carrying this experiment, you should get to know that when you start with the diagram, you are free. If they say describe an experiment, you can describe without a diagram. But if they say with the aid of the diagram, describe an experiment to verify the principle of moments. Here they need to verify the clockwise is equal to the anti-clockwise moment. So what you get to know, the diagram is here. We have the diagram. This is our meter rule. Meter rule. It's called meter rule, not a meter ruler. Meter rule. The one we use in our lab. We have knife edge. We have this knife edge. Knife edge. So, when we are verifying this, it's like having this ruler. And this is our knife edge. What you do, you first balance a meter rule and the knife edge. Balance a meter rule on a knife edge and note the balancing point. That is the first procedure. That's why you get this meter rule and you try to balance. After that, a known weight, W1. A known weight, W1, is suspended on one side of a meter rule, or is hanged on one side of a meter rule, as shown above. Now, when this W1, we say that a known weight is suspended or hung on one side of a meter rule. This is our meter rule. At a known distance, x from where? From the pivot. Another bridge. Now from there, another weight W2. Another weight W2. This is W2. Is suspended on the other side of the meter rule and adjusted. And what? Adjusted until this meter rule balances again horizontally, until this meter rule balances again horizontally. We are just adjusting. Adjusting what? W2 is moving to and fro until a meter rule balances again horizontally. And what we are going to do here, we note the distance y from where? From the pivot to the W2. We note that distance and we call it in centimeters. From there, it is found that the sum of clockwise moment is equal to the sum of anti-clockwise moment. Like this, we are going to try to do this. The clockwise moments is equal to anti-clockwise moments. Where we have clockwise W2 times Y. That's why we have that. Is equal to W1 times X. That is the way how we verify the principle of moments. Through my words, you can generate your own notes. The first one, with what we first do, a meter rule is balanced on the knife edge. This is our knife edge. A meter rule is balanced there, and we note the balancing point. It's balanced like that. And you note the balancing point. You note that balancing point. After you suspend a known weight to one side of the meter rule at a known distance. When the distance is known, you can say the distance, I'm going to use 10, and I press that. From the where? From the turning point, or from the pivot. And you try to press another mass the other side. When you press another mass the other side, W2, you try to adjust that mass. When this one is not adjusted where there is the knife edge. So, towards the end, you are going to see that this one is equal to the other one. And allow me to talk about also the couple, or what they talk. When I talk about the couple, I don't mean the other couple of yours. This is under what you call the turning effects or moments of force. So, we talk about the couple. The couple or the torque, in bracket, parallel what? Parallel forces. When we talk about the couple, there is a moment of a couple and there is a couple. These forces, there must be parallel, but moving oppositely. Moving what? Opposite. Whose line of action do not meet. Whose line of action do not meet. It's like having the two forces. If this is our beam, we have the two forces. Force here, force there. They don't meet one another. These two forces, opposite and parallel. They act on this one, but they don't meet. Let us have a definition for that. A couple, the first two, a couple refers to as two forces, two equal and opposite opposite, parallel forces, parallel forces, whose line of action do not meet. They can say define a couple or define a tau. These are two forces, equal, opposite, parallel forces whose line of action do not meet. So we have also the characteristics of a turning effect of a couple. We have also the applications of a couple. We let us first begin with the other part where we have the characteristics of a body and action of a couple. Characteristics of a body under the action of a couple. Dear my students, here you should get to know that when a body is under that action of a couple, the forces acting on this body, they are the same. That's why the net force over the resultant force is qualified to be 0. And they have what you call the rotation effect on them. They have what you call rotation effect. And also we know that the force acting oppositely. These two forces acting oppositely. That's why we're going to say one. We say that the resultant force on the body is 0. Another one we have the turning force, the turning effect of force, cause a rotation effect. And finally, the forces acting in opposite direction. What you should get to know that there is set a question. Let's say, which one of the following are the sum of the effect when a body is under a couple? They give you normally 1 this, normally 2 this, normally 3 that, normally 4 that, and they say A, normally 1 only, B, normally 2 only, like that. So you should get to know the definition, the sum of the characteristics of the effect of a body when it is under a tension of a couple. We are going to talk about also some of the applications. What are the examples where this moment of a couple is Applied. Applications of a couple. Now, what you should get to know. Application of a couple. Need the examples. What were these couples applied? Like closing and opening of a door. You try to close the door, you try to open the door. It goes, it comes back. But the forces are acting oppositely, and there is rotation effects on it. There is also car steering. Car steering is what you call in Uganda just talk about the steering. When you are moving in Greece, you are moving the forces, but they are moving in the opposite direction. This side like this move and this one like this. When you go like this, you go like this. There is what you call rotation effect. That's one of examples of a couple. There is also the bicycle handle, where the right and the bicycle handle. You move at the corner, you let zoom, and you run like this. That is one of the example of a couple. So, we have also opening and closing a tab. You have very many tabs at home. You try to open, you try to close. There is a rotation effect. So, we are going to talk about also moment of a couple. Moment of a couple. When you talk about moment of a couple, they need a definition. It is not different from the other moments. But here, since we have two forces, we select one force. We select one what? One force, and we're going to say this is the product. This is the product. The product of one force. We talk about one force. Don't just say product of force, but we say of one what? One force. And perpendicular distance and perpendicular distance, ideal distance between two forces. Between two what? Two forces. So, even if they give you a question where we have the two forces like this, where we have the two forces on the edge, we have 20 newtons, and we have the distance from here to here is 5 meters. So, does not mean you are going to use the two forces. We take only one force. The moment of a couple is equal to force. One force times the distance. And you get the answer in what? In newtons per meter. That is the way we can answer that, but you will find in the objective most of the time. We are going to talk about also the conditions. The conditions. We have some of the conditions for a body to be in here. Conditions. For a body Equilibrium. But the body is what? Equilibrium. We have the two conditions. When a body is in equilibrium, and the first condition, we talk about the sum of clockwise moment about a point. About a point is equal to the sum of clockwise and anti-clockwise moment are about the same what? Point. That is the first condition. Another condition, we talk about the sum of forces in one direction is equal to the sum of forces in opposite what? Direction. We are going to get to know those two conditions. Or we say the negative force is what? Zero. What the resultant force is what? Zero. The body to be in equilibrium, those two conditions must be applied. To be in equilibrium means that when it balances horizontally, it's not moving this side, it's not moving the other side, but it is on one what? It is balancing horizontally, does not go this side, does not move the other side. So that is being called equilibrium, my dear students. Here, we are going to say the sum of forces, the sum of clockwise moment, the sum of clockwise moments, the sum of clockwise moments about any point, about any point, about any point is equal to the sum of anti-clockwise moments about the same point. As the first condition. Another condition, we talk about the sum of forces, in one direction is equal to the sum of forces in opposite direction. Or we can say the net force is zero, or the resultant force of the force is what? Is zero. That one also can work. What I mean is this. If we try to consider the diagram to try to describe these two forces there, what I mean this. We have the knife edge there, we have the force where there. I mean these forces. If we have 20 newtons, we have 20 what? Newtons, and we have this one, we have force there, which is 10 newtons, and we have another force where there, which is 30 what? Newtons. When you see this one, and you add the sum of forces in one direction is equal to the sum of forces in opposite direction. That I mean when you try to add 10 plus 20 is good. 10 plus 30 you get 40, and 20 plus 20 you get 40. These two forces are equal, but they are in opposite direction, which implies that the beam over the body is going to be in equilibrium. And therefore, the sum of clockwise moment and the anti-clockwise moment must be the same, must be equal. That's why the body to remain in equilibrium. When you try to move from there, we are going to talk about also what we call the center. The center of gravity. If they are not this is the center of what? Gravity. We are talking about acceleration, the gravity, whatever. We need to get to know the center of this interval is where? Where is your center? Have you identified your center of gravity? Where the weights act most? So, in this we try to get to two methods to find the center of gravity. The first method for irregular objects. Irregular objects like a ruler. Irregular objects like a triangle, like a square, like a circle. You can get the center of gravity. And you have an irregular object like a stone or like this what? Mortar. It is irregular as a shape. So that when it will carry out experimental. So, what you will get to know, the center of gravity, what we call COG, you need to know the definition. This is the point. This is the point of application of the resultant force due to the attraction. Due to the Earth's what? Attraction. You should get to know the definition of center of gravity. Due to the attraction on each, attraction what? On each. In the other box, we're going to find that this is where the weight of the body seems to be concentrated in. This is where the weight of the body seems to be concentrated in. Is another definition. But that one, you should get to know. They say define the center of gravity. Well, I told you that we have methods of defining the center of gravity. We are going to talk about the first one, regular manner. And you get to know how are you going to identify the center of gravity of a regular manner like a metal rule. So here you should get to know that we have, when we talk about regular objects, regular objects determining. Remember we have determining the center of gravity. We apply the two methods there. where we have regular lamina, regular objects. Regular objects, one we have a meter rule. A meter rule. What you call a meter ruler? You are working language. So the meter rule, if you have a uniform meter rule, for us we use the uniform meter rule in our lab there. From 0 to 100 centimeters, its the center of gravity must be at 50. Mark it in the middle. In the what? In the middle. This is the center of gravity. Act in the middle. That's why the weight mg. Its weight acting where? There. This is the center of gravity. When we come about to the curve, we do line of symmetry. We have very many line of what? Symmetry. This one has very many line of what? Symmetry. This is the center of what? Gravity. And when we talk about the square, we do the same. The square applying the same concept here. The square this is our square. The moment you draw a trace, this is the center of gravity. COG. Our square. The rectangle. The center of gravity, we have two lines of symmetry. When you join the diagonals, that one to that, this one is the center of gravity. For regular objects, it is very simple. We use what we call the symmetry, line of what? Symmetry. But we have for irregular objects, like a stone, like what? A stone, like maybe here we use the regular lamina. Regular what? Lamina. For this case, what we do here, there is experiment to determine the center of gravity for experiment to determine the center of gravity for irregular objects. In bracket, we talk about lamina. Must use that. What do you do here? In our lab, we have what we call a stand. We have a stand. We have pendulum, dog, pendulum. When we have a stand, this is what we call a stand. When you have here, we have it, but we have that. That is the grapper. We have little stand, little stand. Now what we do, we have a regular lamina here. This is our regular lamina. This is our diagram. What we do, we make videos are made on a regular object which is lamina. Videos A, B, and C. When the videos are made on the regular lamina, remember I wanted you to find the center of gravity. A pendulum line with the bow is tied at the end A. After that, at the other A, and hung on the little stand. After that, both the regular lamina and the pendulum, one pendulum line bow, and make the swing at once. They make the swing at once. It goes, it comes back. When the bow and the lamina stop, what we do, we draw a line through the sequin of the pendulum and attaches the edge of regular lamina. The experiment is repeated for all B and C. When the experiment is repeated for all B and C, where the two lines meet is the center of gravity. That is the way we determine the center of gravity for irregular objects like that. Because this is irregular, we don't use the other scenario. So, what we are going to do, we're going to give the procedures slowly. In terms of bridge, we have the figures, A, B, and C. A, B, and C are made on an irregular lamina. In different corners. The lamina and pendulum, that is pendulum bow, are made to what? We swing. I'm going to swing through hole A, and when swinging, stops. Or a line. Swinging stop. A line is marked or drawn mapped along the seed string on the lamina. Average the experiment, what the procedures, the experiment is repeated with or A or B and C, and where the line meets, where all line meets, where the lines meet is the center of gravity. The center of gravity. My dear listeners, my dear students, for today we are going to stop on that. But when I come back next time, I'll resume from there. But we have very many questions in the question banks. I know that you have the question banks at home. Most of you you try to get the question banks. Majority of you have, you borrow, and you can check every year. Paper 1 and paper 2, a question almost here. In paper 1 and paper 2. But you should get to know that. Take care of yourself when you are at home. COVID is real, COVID is there. Keep social distancing, also wear your mask. And also, unnecessary movement, please stay at home. I wish you the best. I mean, as at Liga Hussein, teacher of physics and mathematics, but this concept, senior to 1. Bye-bye.